Is it okay? So we have seen that when light is passing from air to a denser medium like glass, it is not going to go in a straight line, but there's a bending which is taking place. So this shows that there is a bending, that means there's a refraction taking place. In addition to refraction, what is happening? This white light is getting split up into 7 different colors. And what are those colors? We know that it is VIB, GY, OR. Okay? So we know that white light, it appears to be white, but actually it is made up of 7 different colors. So what is this phenomena called? This is what is known as dispersion. So you see that the 7 different colors are already forming here. In addition, what is happening? Once again, it is coming out from glass. Once again, it is coming out to air. Okay, from a denser medium, again it is coming out into the rarer medium. Once again, there's going to be a refraction. That means once again, there's going to be a bending. So you find that this bending is also going to be taking place. Okay, and if you catch this light on a screen, for example, if this is your screen, you find that all these colors are going to be formed. Starting from the bottom, what is the color which is here? Right at the bottom?
Violet.
Violet. So this is going to be violet because violet light is the one which is bending the most. Okay, so this is violet light is the one which is bending the most, and then of course you have the red light here. Is that okay? Did all of you follow this part? Yes. So this is what we have completed last time. So we have seen that there is a formation of a spectrum. Not only is the spectrum, but also there is a refraction taking place. That means a bending of light. Now we are going to study this particular phenomena more in detail because many of the natural phenomena that we are talking about, like for example the formation of a rainbow, it is based on the same effect. Okay. So basically what is happening here, the next part of it, if you look at your textbook, is the formation of a rainbow. So you find in nature, basically you have this rainbow with 7 different colors. It's a very beautiful phenomenon. But actually, if you look at it very closely, you'll find that this phenomena of formation of a rainbow is based not only on refraction, but it is also based on the phenomena which is called as a dispersion. So we are going to see how and where such type of rainbow is formed. So we have here, okay, when it starts raining, basically you're talking about raindrops. It's not just a few, but it's going to be in millions. All those tiny droplets which are actually suspended in the air, and of course when it falls down, it's coming down due to gravity. But at the same time, will you notice that rainbow is also formed on a sunny day?
Yes.
Okay, it's not that every time it rains you will not be able to see the rainbow. It should be nice and bright. At the same time, there is a little bit of rain, then you will be able to see
Not
this.
compulsory rain, even if we're watering our garden.
Exactly. If you're having a mist, or if you're standing near a waterfall, or if you're standing near a fountain which is creating a lot of mist in the air, then also you will be able to see a faint rainbow. So what is basically happening? Each of those drops which are falling down is behaving like a tiny prism. So just as we have seen what is happening in a prism, so in a prism what is happening? You are finding that there is a bending of light taking place. That is nothing but refraction. And also at the same time, you will find that there is a spectrum formed because of the dispersion. So similarly, you are talking about each of these raindrops which are present, which behaves exactly like a prism. Why should it behave like a prism? Obviously, because this is made up of a higher refractive index. This is nothing but a raindrop. Okay, so this is a water drop. So light, when it is entering from a rarer medium to a denser medium, it is going to be a bending taking place. Not only is there going to be a bending taking place, but you will also find that it is breaking up into 7 different colors. Now, this of course is a very magnified diagram, but actually, if you look at it, each of these raindrops is a small mist. And just imagine that raindrop is acting as a prism. When the light is entering through it, there is not only a bending which is taking place, that is a refraction, but also a second phenomena which is going to take place. And what is that is called? That is your dispersion. And at the same time, so you see here at this particular point number 1, you find that there's a refraction taking place. Okay, there's a very slight bending which is taking place. Plus, again at the same time, what is happening? It is breaking up into 7 different colors. That means the second phenomena that is taking place is your dispersion. Now, at a particular angle, when it hits this surface, did you see that? That is the surface of the raindrop. It undergoes what is known as total internal reflection. Okay, so this is another phenomenon that you will notice, that there is a total internal reflection. Notice the word, I'm using the word reflection, not refraction. Okay, why? Because this is behaving as a mirror. What happens in a mirror? When the light is striking the mirror, this is incident light or incident ray, it is coming back into the same medium, isn't it? So it is behaving like a mirror because when it is striking this particular surface, it undergoes a phenomenon which is called as reflection. That means if you are taking this to be the back portion of the raindrop, when the light is striking here, there is a reflection and it is coming out. Okay, that takes place only at a particular angle of 42.8 degrees. Not all the raindrops will behave like this. Only if the sunlight is entering at a particular angle, only then the total internal reflection takes place. So why are we talking about a total internal? That means the ray which is striking here is coming back again into the same medium. It's not going out. Have you followed? Refraction, of course, can take place in many of the raindrops. We are not bothered about many raindrops. Through many of the raindrops, it might enter here, it might come out. Okay, that is behaving just like in this particular case. But here, what is happening is there is a total internal reflection taking place. That means once again it has taken a turn and it has come back again into the same medium. So we have here, which there is, it has come back again into the same medium. Have you followed? So the rays are entering. Once again, it has taken a turn and it has come back. Now, what is happening here at this particular point? Will it stay inside the raindrop or will it come out? It has to come out. Okay. So once again, from a denser medium, which happens to be water, it is coming out into a rarer medium, which is air. So what happens here? It moves away from the normal. So you find here that there once again taking place and it is moving out of the raindrop. And this is where you get the 7 different colors with red on the top and the violet green. Okay, so we have here 4 different events which are taking place. Have you followed? It's a beautiful phenomenon, but it is just what we have shown here is just only for one single drop, which is actually behaving like a prism. But just imagine there are millions and millions of drops which are present. Okay, that mist which is actually present, and this particular phenomena is taking place in each and every raindrop, and the cumulative effect is what we are getting as a raindrop, as a rainbow. Is that okay? Let's revise once again. What's happening? What's happening at 1? What's happening at point number 1?
Light is entering.
Points. Sunrise is entering. So what is happening here at point 1? Refraction. Why is it refracting? Because it's entering from air to water. That means from a rarer medium to a denser medium. Then, as soon as it enters into the denser medium, what else is happening? Not dimension, it's breaking up into 7 different colors. So what is that phenomenon called? Dispersion. What is it called? This is dispersion. Okay. So this is nothing but dispersion. So what's happening at point number 3? Total internal reflection. Why are we calling it as total internal reflection? Because the light rays which is hitting the drop is reflected and it is coming out. Have you followed? And once it reaches at point 4, what is happening? Once again, it is undergoing what process is happening here? Denser medium to a rarer medium, क्या होगा?
Dispersion.
No dispersion. Dispersion is already taken. Diffraction, nothing but diffraction. So refraction is taking place at 2 positions. What are the 2 positions?
First and
worst. Yes, first and fourth. So this is basically emerging. Because it's emerging out, you can say diffraction is taking place. So this is your incident ray. Okay. Here it is getting refracted. Here it is getting totally internal reflection. And once again it is coming out. Is that okay? And have you noticed that we said that raindrop along with the raindrops which are present, a source of light is very essential. Okay? Here, of course, we are talking about sunlight. Okay, so sunlight should always be present behind us. So that is how we will be able to find the rainbow. So sunlight is falling onto the rain drops which are there. You actually get a rainbow, and that's how you will be able to see. Have you followed? And like we have already discussed, it's not only whenever we are getting a rainfall, but whenever there's some kind of a mist. Like for example, if you're seeing some kind of a waterfall, okay, but there's plenty of mist in the air. Like for example, if you go to Niagara Falls or if you have seen Niagara, or probably even in one of these Lonavala, no? Once it's after a heavy rainfall and if there is nice sunshine, yes, you'll be able to see a nice rainbow. You'll be able to see a rainbow. So what is essential? You must have mist.
And sometimes in mushrooms.
Actually, we don't have. What I'm saying is not a natural phenomenon. Definitely. Then,
Sector 14.
okay. So what is essential? One is the source of sunlight. It may be sunlight or it could be bright lights, neon lights, anything is possible. Second thing is you must have a source of mist. So it can be through a natural rainfall, it can be a fountain, okay, or it can also be a spray or something of that sort. As long as we have raindrops or drops of water which are suspended in the air, you're getting this natural phenomenon.
Now the rainbow can be formed in night time.
No, definitely not a source of light.
But in the evening it can be.
Evening, but there is still some sunlight, no? As long as there's sunlight, natural source of sunlight, you definitely have. Not after sunset. You will never find anything after sunset. Is that okay? So we will read the first part of it and try to understand whether you have understood all these different points. Ready with your pencil? Somewhere in the last paragraph there, any light
that gives us
yeah, similar to that of sunlight is often referred to as white light. I'm reading the last paragraph, pay attention. The rainbow is a natural spectrum. Underline the word natural spectrum. There are certain words that I need to, you need to stress on, so I'm asking you to underline. Appearing in the sky after a rain shower. It is caused by dispersion, underline the word dispersion of sunlight, by tiny water droplets present in the atmosphere. A rainbow is always formed in a direction opposite to that of sun, not in the direction. It is always in the opposite direction of the sun because the sunlight has to come and fall on the raindrops, okay, not in the same direction. The water droplets act as small prisms. Underline the word small prism. They refract. Underline the word refract.
and disperse.
Disperse the incident light. Dispersion is taking place at which point? Point number 2. Did you refer to the diagram? Point number 2, dispersion is taking place where white light is splitting up into 7 different colors. Then reflected internally. Underline that word. Reflection is taking place internally. Okay, so that's basically what is known as total internal reflection. And finally, refract again. At which point is the final refraction taking place? Twice here, at point number 4. So finally, it is getting refracted again at 4. So point number 1 is a refraction. Point number 4 also there is a refraction taking place. Okay. Due to the dispersion of light and internal reflection, different colors reach the observer's eye. Okay.
Right, the colors which we see are observed from the point 4.
Yes. What we are actually seeing is that because the water droplet is here, the raindrop, the sunrise is going inside, coming out, because basically this is acting like a prism. So just as we are talking about a prism, the white light is entering here, and what we are able to see is the spectrum here. So basically, it is acting like a prism.
When the human eye plays a vital role.
Why should it?
Like it has a lens.
No, that of course is there. See, whatever we are seeing around us, we are able to perceive it. But actually, what is the phenomena which is happening inside the rainbow, isn't it? Inside the raindrop itself. Okay, we are able to see different colors. Don't you see all these different colors? It's anyway taking place. So that is the light which is entering into our eyes, how the refraction is taking place, and it is perceived by the rods and the cones. So that's a different concept. Okay. Now you can also see the rainbow. Anish, on a sunny day, when you look at the sky through the waterfall or through a water fountain, but what is essential is the sun should be behind you. That is important. The sun should be behind you. So as long as there's mist in the air, okay, maybe in a fountain or even a waterfall, you will be able to see the water, the rain. So they've not only this, it has to be suspended in there. Yes, it has to be. See, if it's a small waterfall, there's not much of.
sprinklers in ground farm. You can also see rainbow over there. The sprinklers.
Yeah, that's what I'm saying. As long as if you're talking about your sprinklers, which is creating a mist, only then you will be able to see. Okay, and of course, we should have a natural source of sunlight. Next page, we are talking about atmospheric refraction.
Also, you can see that rainbow colors like when in rainy season, oil is leaked from some vehicles and water flows.
Yeah, that is it. Yes, that is correct. Basically, it is also because of refraction decrease. Correct. Okay. So now we are discussing about atmospheric refraction and what could be the various phenomena that you might see. One of the things that you might have noticed, especially in summers, so when we talk about atmospheric refraction. Now we are back again to refraction, don't get confused. It's no longer reflection. So I don't know whether you people have noticed, suppose you're going on a long highway or something of that sort.
You can see that there's water over
Yeah,
Yes,
the
yes, yes.
highway, when you're driving on a highway, you feel, yes, in summer, you feel as if there's something that's
Water.
floating.
But when you go near,
There's nothing.
because of the heat waves.
Yes. Okay, so what is happening here? Let's try to understand what is actually happening. This is the road. Imagine that this is the road, and the road obviously is getting heated up. So what happens is the air which is next to the road also is getting heated up. Okay, but imagine that there are different layers of atmosphere. Can you imagine that? So if this is getting hot, the layer which is next to it is obviously hotter. This is very, very hot as when compared to the layers above. So the layers above are much cooler as when compared to the layers of air which is closer to the road. Okay, so what is happening? There's a change in the refractive index, a very small change in the refractive index, depending upon the layers of air, depending upon what is hot and what is cold.
Even when we see like the fire is like there.
I'm coming to that. I'm coming to that. Okay. So that is why when you're talking about the sun rays, when it passes through so many different layers, you find that it is wavering. Probably you would have also seen during that Holi Cup, when we do that Holi, we light up a bonfire. Okay. So suppose somebody, you have the fire in front of you and there's somebody who's standing behind, you will be able to see that that is wavering, isn't it? Once again, what is happening? The heat is actually heating up the air around.
in boiling oil.
What?
Oil also.
Oil.
Yes.
The steam is of course coming out, whatever is steam, and you can actually find the wavering.
Also
Okay.
gas.
Yes, yes, that is true. So what is basically happening? It's actually the heat, the atmosphere or the air around the source of heat, which is actually getting heated up, and it becomes lighter. Hotter air definitely it is going to be. So you find that the refraction is taking place in many, many different layers, and that is what is causing this wavering of light. Have you followed? Is it clear? Yeah. We read the next paragraph about atmospheric refraction, and many of the things that we will talk about now is based on this atmospheric refraction. You might have observed, are we ready?
Yes, sir.
The apparent random wavering. What is the meaning of the word apparent? Appears to. Apparent. That means it is appearing to be. Right? The random wavering or flickering of objects seen through a turbulent stream of hot air. So as long as there is turbulentness, it is something that is moving, it's not stationary. Okay? Stream of hot air rising above a fire or a radiator. So wherever you have a fire, like probably you have lit a fire, it is a bonfire, or even it is a flame, open flame, what is happening is the air around is turbulent, right? Kinetic energy, heat energy is getting transferred, and obviously the Air molecules are very turbulent. So this is the apparent random wavering. The air just above the fire becomes hotter. Underline that. The air just above the fire becomes hotter than the air further up. The hotter air is lighter and therefore it is less dense than the cooler air above it. And therefore it has a refractive index slightly less than the cooler air. So which has more refractive index and which has less refractive index? Hot air. Hot air has got cold air. Hot or I'm talking about hot air and cold air. So which has got that denser? Cold air has got more denser. Okay, so refractive index is more for that of a cold air. Okay. Then, since the physical conditions of the refracting medium, what is the refracting medium here? It is nothing but air, are not stationary. It's not constant. Refractive index of all these layers of air is not constant. Okay. So sometimes it's very hot, refractive index is less. So here it is colder air, the refractive index is more. So since there is a wavering taking place, okay, the apparent position of the object as seen through the hot air fluctuates. Underline that statement. I want you to use this word. There is a fluctuating because when you're seeing the object through the various layers of air, it is fluctuating. Okay. This wavering is an effect of atmospheric refraction of light by the Earth's atmosphere. This, of course, what we are talking is a small thing that is happening in our day-to-day life. Okay, wherever we are able to see objects next to something that is very hot. So we have spoken about fire. We have spoken about an open flame. We have also spoken about a hot surface like a hot tar road. Okay, so how the objects appear to be flickering. Next thing is what you are going to see is the twinkling of stars based on the same type of a phenomena. But now what is happening is it's a very huge phenomena that is happening in the universe. Okay, so if you have understood this particular phenomena of why it is fluctuating, then you will be able to understand refraction which is taking place through various layers of air. So when we are talking about the stars which are twinkling, let's say this is the Earth, right? And the Earth is surrounded by the atmosphere. Correct? Does this atmosphere extend right up to the throughout? What do we have here? Vacuum. Vacuum. There's nothing there. Okay. So when we are talking about an atmosphere, it is nothing but a blanket of various gases which are present. It's only next to the Earth that you have this atmosphere.
Even darkness.
Yeah, that is there. We'll speak about it. That space and what is going to happen here. So when we talk about the atmosphere, what is it made of? What is it made of?
Various gases.
Gases, various gases. What are the major ones which are present in the atmosphere?
Nitrogen, oxygen.
Nitrogen and oxygen. Basically, we are talking about nitrogen and oxygen, and of course various other gases like hydrogen, inert gases, etc. In addition to it, we also have got drink some water because you are drinking water. See, okay, dust particles and water droplets also. Is that okay? Here, when you see, once again, it's not one ordinary or stationary type of layer, but you will find that there could be different layers. Imagine that there are different layers. The layer of atmosphere, which is very close to that of the Earth, is obviously much more denser. What happened? Somebody has to scare you now. Anish, if I scare you well, no, then that thing will pick up a lot automatically stop. Enough, enough. Don't drink too much, it'll automatically pick up. It's okay. No, let it be, it'll be all right. Don't disturb it, it'll be all right, fine. Okay, So what are we talking about? The various layers of atmosphere which are present around the earth, and that's not stable. Okay, so you find that it is much more denser. That means the molecules of air are much more denser as you're coming closer to the earth as when compared to the other layers. So it is rarer to denser. If you understand now what I'm saying, sunlight has to pass from a rarer medium to a denser medium. So what is happening? Is it passing in a straight line? From a rarer to denser, क्या होगा? There's a bending taking place towards the normal. So at each and every point, what is happening is, suppose you're talking about the sun rays, it's not going to pass in a straight line like that. Okay? If you actually have to see, there's a slight bending taking place. Next, it comes to the other layer. Once again, there's a slight bending. There's a slight bending. Okay, so that is how we find that the sun rays, instead of a straight line, there's a slight bending which is taking place. So for the person who is going to be standing on the surface of the earth, right? The apparent position of the star. Now, what is star? Star is nothing but a sun.
But how will the light, the light will pass to the focus?
What focus?
Like if we, the experiment of leaf,
Experiment of?
leaf, like the light, if we put a magnifying glass and the leaf, the sunlight passes to the focus, then the leaf starts burning.
Huh.
So how will the light?
No, there is no lens. There is no lens which is here. See, when you are using that experiment of the leaf which is burning, you are actually using a convex lens and you are bringing the sunlight in focus. We are not asking any, there's no focus taking place, no.
No, if the light diverges like this,
That's all, it is only bending which is taking place. Now just imagine you have got a series of, let us say, I'm having cylinders and each one of them is filled with a different type of a liquid. Suppose I'm having A, B and C. Okay. Now let us say the light is passing from A, it is passing through A. Okay. Let us say A is very, very dense. So instead of passing through a straight line here, it is going to bend. This is going to bend towards the normal or away from the normal?
Away from the normal.
Yes. Away? Rarer medium. This is, yeah. It is going to bend towards the normal. So at every step, it is going to bend towards the normal depending upon whether it is rarer or denser. That's exactly what is happening here. We're not focusing on anything. Have you followed? Okay. So, come back again here. I hope you people have understood. So what is happening is there is a bending which is taking place at every point when there is a change of refraction of air. Now we are talking only about refraction of air, and there's a very small subtle type of a difference. So there's a gradual bending taking place. So therefore, when a person is standing on the surface of the earth and when he's looking at the star, what he sees is the apparent position it is appearing to be much higher than actually it is. Have you followed what I'm saying? So the star is somewhere here, the actual star, but the person who is standing here, it appears as if it is somewhere up here. So that is the apparent position because there is a difference in the refraction of the refractive index of the layers of the atmosphere. Have you followed? So basically what is happening here, there is a refraction taking place. Why is there a refraction taking place? Is because the layers of atmosphere do not have the same refractive index. It keeps on changing. Okay? It is rarer on the outside, and as you're coming closer and closer to the earth, it becomes denser. What is it?
Like you can say in vacuum light bends a bit.
No, in vacuum there is no problem at all. Absolutely. This is the sun. Suppose the sun is very far off. It travels in a straight line. That's no problem at all. But as it is coming closer and closer to the earth, because there are differences in the refractive index, that is where the
Like it appears to us that it is bending, but it is not. The light is bending.
Yeah. Then if, for example, if you're talking about space, it's a different thing. Because there are two other phenomena that we are talking about when you look at the sunlight when you're on the surface of the earth. We'll come back to that, whether we are talking about sunrise or sunset. Okay, so that is another one. So till here, did you understand? So when we say why it is twinkling, because this is a point source, because it's a sun and it has light of its own. Okay, so it's producing light. So therefore, because it's producing light, it's considered as a point source. And because of the wavering of the light, of the bending of the light, it appears slightly higher than its actual position. So that's why you will find that it is a small movement, and that's why we call it as twinkling. Have you followed? But at the same time, if you're talking about a planet, what happens to a planet? Is planet closer to the Earth as when compared to the stars? The solar system, our sun is the only closest sun. Have you followed? All of the stars are very, very, very far. So when we are talking about the planets, like for example, if you're seeing the Venus or the Mars or whatever it is, it's definitely much closer. So what happens in the case of a planet? Does it have light of its own? No, there's no light. So it's only just, there's no light at all.
Some planets have like Venus.
It is a reflected light of the sun. So when the sunlight falls on the planet, it is getting reflected. So it has no light of its own. It appears to be red or it appears to be blue. That's
No, it's
because
naturally hot and it's burning on Venus. Naturally,
see, it's not like the sun. It's not like the sun, or it is not like a star. Then how do we define what is a star? Star is nothing but a sun which has got actually light and it is glowing on its own. Okay. So here, since it has no light of its own, and it is only the reflected light, and it is much, much closer. So you can take a planet to be a collective point of many, many sources of point lights. So if one part of it becomes dim, the other part is becoming brighter, and therefore it sort of averages out. And that's why you don't find that the planets are actually twinkling. They don't twinkle. So the planets are not going to twinkle, whereas the stars are going to show this twinkling phenomena. That's one, because of the distance, and second is because we are looking at the starlight or the sunlight, which is passing through various layers of atmosphere, and that is how it is reaching us. Is that very clear? So we'll read that last part about the middle paragraph, twinkling of light. Garan, read the twinkling of
the
star.
twinkling of stars.
And read it slowly because we need to underline certain words there. Yeah, Anish, would you like to leave the class? Please behave yourself. Okay.
The twinkling of a star is due to the atmospheric refraction of a star.
Underline. What is it due to? Atmospheric refraction of starlight. Why are they saying starlight? Because star is the one which is actually producing the light. Okay, next.
The starlight, on entering the Earth's atmosphere, undergoes refraction continuously before it reaches the Earth.
Underline the word refraction. Why should it undergo refraction? That is the next line.
The atmospheric refraction occurs in a medium of gradual changing refractive index. Since the atmosphere bends starlight towards the normal, and the apparent position of the star is slightly different from its actual position.
Underline. Apparent position is different from its actual position. Suppose the star is here, apparent position is slightly above. It appears as if it is slightly higher, and that is because of refraction. Yes, continue.
The star appears slightly higher above than its actual position when viewed near the horizon. Further, this apparent position of the star is not stationary, but keeps on changing slightly, since the physical conditions of the Earth's atmosphere are not stationary, as was the case in the previous paragraph. Since the stars are very distant, they approximate point size source of light.
Stop
As
here.
the
Stop here. Do you understand? Stars are very distant. Because they're very, very, very far, it appears just as a point for us. In fact, the sun is so much closer as when compared to all of the stars. So at least in the sun, you will be able to see that there's a nice big blob in the sky. But the stars are so much further away that it just appears as if it's a small, tiny point. Okay, continue. As
the path of rays of light coming from the star goes on varying slightly, the apparent position of the star fluctuates and the amount of starlight entering the eye flickers. The star sometimes appears brighter and at some other time fainter, which is the twinkling effect.
Have you understood? So why is the star light? Why is the star actually appearing to be actually twinkling? Is it actually twinkling? No. Why is it appearing as it is? Obviously because of atmospheric refraction. Because it is entering through various layers of atmosphere, having different refractive indexes. Okay, from a rarer medium it is coming to denser medium. So therefore it is always bending towards the normal. Okay, so the apparent position is much higher as when compared to the actual position. That's the next paragraph. That is what we do. Okay. Before I go on to the planets, which I have already explained to you. A
But
couple
the
of
stars are also burning more like sun.
yes,
So why don't they like?
that is because of the distance. Sun is so much closer. Okay. And when compared to the star, it is so much farther away. See, this is what is there in the twinkling star. No? Most of us have. You remember the KG poem that we used to learn? Little star. Why does it appear to be little? No, it's very tiny. Little star. Why do we say little star? Obviously, it's very far. Okay. How I wonder what you are. Up above. World so high, so it's obviously very, very high. Like a diamond.
Phenomena that the stars can see that there is a dinosaur like a time in
Due to light.
yes.
Because
Light has not yet reached.
because of the
So they are actually seeing the time before.
basically what you're talking about the time lapse.
Yes.
Takes so many years for the starlight to reach the earth. Okay, so what the light which has actually left the earth is so much more before as when what we are actually seeing now. So that is the time lapse phenomenon. Come on, take down a couple of points before we go on to writing down about the planets. Last time did I make you draw?
Yes, ma'am.
ये वाला हो गया ना? Manish, come and sit in the first bench, please. You will talk to me.
Ma'am, he was asking me what is the noun, so I asked him.
Come.
So I told.
You come. Okay. Okay, the next thing that we are writing. Formation of a rainbow. Heading, your heading will be formation of a rainbow. I'll give you certain important points. Use those points for writing down your answer. Ready? Let, yeah, boys. Ready? Formation of a rainbow. First one. A rainbow is always formed. A rainbow is always formed. I'm giving you random. In a direction opposite to that of sun.
Rainbow is always formed.
Listen, I'll repeat, wait, don't repeat after me. A rainbow is always formed in a direction opposite to that of the sun. Next point. The rainbow is a natural spectrum appearing in the sky after a rain shower.
You can also write that this raindrop is a natural prism.
I'm telling you, it will come into the next one. Right? Next one. The water droplets act as small prisms. Next point. Now we are talking about all these points that I had written, point number 1, 2, 3, 4 in the same order. Okay? They refract, next point, they refract and disperse the sunlight then reflected internally,
reflect it
internally. आ गया यहाँ से?
disperse the sunlight
Then it comes and reflects it internally. And finally, it refracts again. Never mind, you leave that now. You continue to write, otherwise you miss out whatever I'm saying. Leave out that line and write down. And finally, refracts it again when it comes out of the raindrop. Okay. Next point. Due to the dispersion of light, and internal reflection, different colors. What are the 7 different colors? Put it in brackets. VIBGYOR, different colors. Close the bracket. Reach the observer.
Reaches the
Observer size, person size. Okay. Another important point that you need to write is a rainbow can also be seen on a sunny day. When you look at the sky, through a waterfall or
sky.
through a waterfall or through a water fountain or through a water fountain with the sun,
We can say that the
with the sun behind us.
Urban, we can say that the object which make mist.
Mist. You can also put down as mist. No. It's not necessary that you by heart the answer. No. I've given you those important points which you should include in your answer. Have you followed? Yeah. So what are the 4 things that you should remember? What are the 4 things that are happening inside the ring?
Direction
First is
reflection,
First-
reflection and
Okay, just write it down. Leave that answer, keep a line and write down 4 points for you to remember. Leave that line. Leave a line and write down 4 points. First is refraction. Second, you should remember that there's a dispersion taking place. The title part of it will make you draw. This is for you to remember. Second is dispersion. Third is internal reflection. At point number 4, again remember that there is a refraction taking place. First and fourth, both of them will be refraction. Is that okay? So even when you draw the diagram, think about these lines and then draw it or sketch it properly. Okay? Next, Take down another question. Come to the next page. We are talking about atmospheric refraction. The question is, why does an object appear to be wavering wavering. Wavering is like wave, okay? When seen through a stream of hot air. Stream of hot air. Okay. Read the first paragraph here. I'll ask what type of questions, what are the points that you can think of, and in what order that you have to write. Only the first paragraph.
Like about the thinking.
No, not the stars. I'm not talking about the stars. Yes, about.
Just about the fire becomes hotter and the air.
Yes. What else will you write?
The hotter air is lighter than the cooler.
Then what else will you write?
And less than that of the cooler air.
Yes. So we are going to talk not only about the temperature, but also talk about the refractive index.
And the apparent position of the object fluctuates.
The physical conditions of less refractive medium are not.
It's not stationary, and therefore the wavering takes place. Did you get all the 4 points? Did you get 4 points there? Come on, write it down. Right. Did you write the question? Why does an object appear to be wavering? Come on, write it down. Start from there. When an object appear to be wavering.
How does you have to write that?
Oh no, yeah, you write it on your own. The air above, just above the fire, because these are points which are quite straightforward. You have a volume, Manish? Volume.
Is also
Almost.
It's motion complete.
Almost. I don't say it is complete because we have one more class. Sit here. Can you do the answer that I've given you? Don't get this. This is a straightforward answer which is given in your text, so it's not much. You've written all the points?
physical condition of the refractive
That is why the wavelength is different. Now these are type of questions that you might expect for a 2 mark or even a 3 mark question. Okay. Yes. Yeah. Read out, let's see what you have written. Read.
the air the fire begins hotter than the air further on the hotter air is lighter, less dense. Refractive index is slightly less than the outward cooler air. The physical condition of the refractive medium are not stationary. The apparent position of the object seen through the hot air fluctuates.
Have you seen? Have you got all the points you noticed? Okay, did you correct or do you have to add anything? Just make sure that you get all the points. Is that okay? Now the same thing can be asked. You can slightly change the question and say when you're driving in a hot road, you can see that the vehicle in front of you appears to be wavering. What will you write? The same answer, except you just have to change the words here and there. Have you got it? Everything that you have to write is regarding. Have you included the word atmospheric refraction? That word atmospheric refraction is very, very important because there is a bending of the light rays when light travels from one transparent media to the other. Okay, so underline the word atmospheric refraction. That is an important word that you must include in this answer. This phenomena is due to the atmospheric refraction taking place in nature. Okay, you can add it as a separate sentence also. Is that okay? Right? Now, the next thing that we need to write is about the twinkling of the stars. There are a couple of points that you must keep in mind. Look at me. First one is it is a natural phenomena taking place due to atmospheric refraction. Talk about the star, which is a natural sun, but it is very, very far away. Therefore, it appears as a point source. Okay. Third point, you're talking about the light which is coming from very far off. But when you're talking about the atmosphere around the earth, it does not have the same refractive index. It keeps on changing. Refractive index is more for the denser air and it is less for the layers of air which is far away. So obviously there's a bending of light which is taking place. Okay, and that basically gives you this effect of twinkling of stars. Okay, so here I was just checking out. They have given, if you are having volume 2, you can check it out. All of you have volume 2? I'll give you yours. So this is on page number 108. Page number 108, the last few lines there. But they have given it to you as a passage which fill in the blanks. Okay, did you get 108? Okay, everybody try to fill up those blanks. Think and do. Write it there. Let us see what answers you get. One zero. write and then we'll see what are the answers. Write it down. Write it with pencil. Do it with pencil. Never mind, do it with pencil. Come to the class without a pencil. Right, almost done. Okay, let's see. Finish?
Reflection.
Nadia, also, there's one more here. Come to the next page, page number 110, 110, and they have given you the answer number 14. Look at answer number 14. Once you are done with the fill in the blank, also go through why the stars are created. That is different, that is basically there's nothing but different.
Mom, the statements are
Okay, so what? That is not the answer. That is definitely not the answer for your fill in the blanks. But they've given you a gist of what is happening for stars, why stars are created. Points are same, but it's not the same answer.
Yes, sir. Sushita. So,
क्या बोलते हैं
Why, what happened now, Gaurav?
yeah, we are feeling cold. It's like
Never mind. Rashita, you don't answer. They're not putting it up.
Why do stars twinkle?
You go and sit in class. Okay, Rashita, I want you to read answer number 14 first.
Stars emit their own light and they twinkle due to atmospheric refraction of light. Stars are very far away from the earth and they are considered as point source of light.
Why should we consider them as a point source? Obviously because of the distance.
When the light coming from stars enters the Earth's atmosphere, it gets refracted at different levels because of the variation in air density at different levels of the atmosphere. When the starlight refracted by the atmosphere comes more towards us, it appears brighter than when it comes less towards us. Therefore, it appears as if the stars are twinkling at night.
Okay, so that's the gist of what is actually given in the text. Okay, now, will you be able to write down this answer now? Okay, so you have got enough material, you have known what are the points that you are going to write. Come on, write. In your notebook, quickly.
Now, same question.
Question is going to be the same. What have you written now?
What is the question?
Question is why the stars twinkling. This is one of the questions which is given here also. In your textbook exercise number 10.
Explain the twinkling of stars.
Here it is given as why do dark stars twinkle. See
It
here,
is the same question.
same thing. But don't copy it directly from there. I want you to express it in your words.
Like, should we write the points like from here or
You can mix everything as
Should we
I
have to write points on
Yes,
directly?
no paragraph. Everything in points. Hurry up. I don't want anybody to copy it directly from the textbook, but you can use it as a source. You can explain it in your own words. Look at the textbook. Use your textbook. number 9 tested.
I also
Now this is usually going to be for 2 marks. 2 marks questions. So that's 5 centimeters.
sometimes these questions they ask for 3 to 4 marks sometimes. And these short questions.
Those are if at all it is asked in one sitting.
Because they ask like
Right.
how many planets are there in solar system?
What?
How many planets are there in solar system?
I never covered on any of them.
Seventh standard, I guess, 10th standard is raised 7th standard correct. Okay, तो paper they correct. चलो लेकिन right that stars are numerous objects.
Luminous, they have their own light.
They emit their
They have their own light. It is a sun. 5 minutes only for you to write, not to talk. Quick. First, you're going to say is stars have their own light, luminous. Second, you talk about the distance, very far away, therefore it is considered as a point source. Most important point, don't forget atmospheric refraction. When starlight is entering into the Earth's atmosphere, it is continuously undergoing atmospheric refraction. Then you talk about the changing refractive index because of different densities.
I think the printing is there. The starlight coming from a very long distance. Here it is written as if from a point source. And we are thinking like the starlight coming from a very long distance as it form a point source.
From a point source.
As if from a point source or as it form a point source.
As if it is coming from a point source.
Not around 3 points.
The starlight
Very long distance.
as if from a point source or as it form a point source.
As if from a point source, it's coming here. As if it's coming from a point source.
But as it form a point source,
It's coming from a point source. It is coming from a point source. Come on, continue. Different densities have you written? The starlight is coming.
Ma'am, I wrote stars emit their own light. They are very far and hence appear to be twinkling. The main cause of twinkling is due to the atmospheric reflection. Starlight.
Or no. Why is it twinkling? What happens to refraction? Atmospheric refraction, why is it taking place? Because the layers of air have got different refractive index depending upon the density. All that you have to write. If you're writing this, it's only half a mark. Incomplete answer. Also write about the apparent position of the star, why it is changing. When you write stars are very distant, you add another point, therefore it appears as a point source of light. तरी add कर सकते हैं, हाँ? So why should it bend? The atmosphere bends the starlight towards the normal. Why is it bending? Because of the various, all that has to be written. वो लिखना. Why is the refraction taking place? Suppose the entire thing was the same, then there's no refraction taking place, right? Right. Okay. In the second point, only add that Anish. Second point, that it appears as a point source of light. It's very small. Stars, what have you written? It's very far off. So therefore, it appears as a point source. And also write, it has got, children, this is very, very important that you have to write about the various layers of atmosphere having different refractive index. And that's why there's a refraction taking place. Right? Was done? Hurry up. Read better. Let's see whether we have covered all the points. Yeah, read.
Stars emit their own light and they twinkle due to atmospheric refraction of light. The starlight coming from a very long distance as if from a point source, while passing through different layers of atmospheric air, undergoes refraction due to the changing refractive index of air.
Yes.
This causes the light reaching us to have radial intensity, but star appearing.
And also write down the apparent position. The apparent position of the star appears to be higher than the actual one. Write down that. Finish. See whether you have included all the points. The apparent position of the starlight is much higher than actually it is. Position.
Apparent position of starlight is much higher.
It's given in the diagram also, you can see that. No? Coming from the stars, force. Yes. Quite exactly. It's very far away, therefore this is having a never in a paragraph like this. If I ever see an answer like this, I'm just going to cut it out. Which I'm going to do it right now. Harold? No paragraph. I've told you many, many times. No paragraph at all. I've told you many times. Never that. Please write it down. No such position. Apparent position has shifted now, slightly.
Some point equality. Hamara point on that.
Nika, finished? Okay, fine. Now, important thing that we need to do is please draw the diagram of the formation of the raindrop. I think it's much more clear here. The textbook diagram is not very clear.
Mom, can you draw it like near like where we have written formation of rainbow?
But you have a base then. It's all right. I'm giving it to you as a separate question. Never mind if you do it. This diagram is, yeah. Here the diagram is quite clear. If you have it, it is on page 101. This diagram is what is required. And label the 4 points. Chalo. Quick. Neat label diagram. And when I say a diagonal, not on two lines, nice.
This one?
Yes, not double, that is rainbow one. What? Rainbow.
No,
This one.
this one.
Rainbow.
It's like the point.
That's quite important. Come on, please.
Ma'am, this one, this
That's very good. It's not bad. Yes, he deserves. What do you want?
but we should not take attention. Of course,
4 times I have told you, it is raindrop that we are doing when you are drawing prism. Show the bending properly, there is a refraction taking place. When you are drawing with a black pencil, we have to label it as red. It is similar to yeah, violet.
It's red and purple is red.
But if the examinations-
Not here.
But suppose we are not going to use that, what will you do? You have to use a black pencil and label it. Label it as red and white. Put that inside.
I do not get a scale.
Put that inside, you're not going to use that as a scale.
Cool.
Never mind, hurry up.
Yeah.
Done? Labeling, along with labeling. What are the 4 points that I told you? What is sunlight? Incident sunlight.
yes.
Okay? And show the red and the violet. Which is the red? Which is the violet? Look at your textbook. No. Always when a rainbow is formed, see what is the color?
This is
Ma'am, this one is violet and this one is red.
Okay, violet.
There's no labeling here?
Ma'am, internal reflection is it total?
Usually we call it as total.
This is
In the
first.
textbook, they are not given
Ah,
us
no.
separately. You have given total internally reflect. Yes. Internal reflection. they are given.
But internal we have to.
You have to use the word.
This is the first refracted layer and this is the second. This one is first.
You have to tell you how to label it. Okay, now what will you write for 1, 2, 3, 4? Where is the labeling? अगर यहाँ लिखा है आपके पास तो लिखो ना, write the index. Show what is happening at each part. Correct. And here inside also there is a refraction. You see the diagram? So they are equal. Only, see, no, only, because in the examinations you are using only your pencil, so you have to label it as red and violet. That's okay. See, yeah. Is that done? Gaurav, I'd like to see your diagram. Hurry up.
You come and do the
I'll come and check.
Sorry.
Okay. Now we come to question number 11 of your textbook.
Last question.
Question 11.
Planets.
Explain why planets do not twinkle. Put a tick mark for 10. We have already done that. Okay. Now we are in 11.
Because they do not have their own life.
Yes. And they are much closer. Okay. So you can say a planet is nothing but a collection of different
Larger number of points.
point sources. So even if one point is coming up brighter, the other point is dimming. Okay, so therefore an average it doesn't, it averages out and therefore there
No, but
is
some planets are made up of gases, so what about
no, as long what they're asking is why it is not twinkling. Okay, basically it is not showing the twinkling effect.
Ma'am, I just wanted a random question to ask. That Mars contains iron in it, that's why it's
Yeah, it's very usually iron oxide is very high percentage of iron. Where just
In
giving
Worldly, I went to Nehru Planetarium. They said that the Mars contains iron
iron.
oxide
That's why it is reddish, yes.
and rust iron.
Yeah.
That's why.
Iron oxide. Iron oxide is Fe2O3. So that's it. Have you started off with your chemistry? Yeah, you did. Second one is there. So second chapter also. That's all about rusty. Okay. Nikha?
Yes.
What? Question, Harit. Why do planets?
Explain why the planets do not.
Ah, right. First point you will write. The planets are much closer to the Earth.
Ma'am, volume the answer.
It's given there, it's given here. You can just make some action. See the planets are much closer to the Earth and thus are seen as extended sources.
And
They are seen as extended sources. Okay? See your sources.
where it is?
We have already read, isn't it?
I mean, volume is written, plants do not twinkle because they appear large in size.
Then the stars are there relatively
Sure,
closer.
sir.
Size matters.
Yes, it does. Yeah. It does because it is coming much closer and moreover they do not have. Okay. Raj, from your textbook, everything is given. Yes, come on, hurry up. We're not here to waste our time. I'm not going to dictate. Come on, hurry and pick up your points and write down. Boys, I hope people are writing it in points. Ah.
And you will be writing
No paragraphs. Never in paragraph. See, children, you're not only writing the answer, but I think you should keep in mind that you're writing an exam, board examination. So your presentation is equally important. Why do you think I'm stressing about all these things? There are lakhs of papers coming to teachers. So your presentation has to equally be good, not only your answers. refer to your volume, the same page, 108, I think. No? There are these answers. See, number 15. You can also refer to your volume. Answer number 15. Whether you have covered all the points.
Planets are much better than the currently said. Planets are a mixture of large number of point-sized sources of light. Different parts of these planets produce brighter or dimmer effect in such a way that the average of brighter and dimmer effect is equal. Hence, planets.
What is nullified?
Nullified. Something is bright, something is dim. So it's getting nullified. It's getting averaged out. And therefore you don't find that quickly.
Planets are not closer to the Earth that is seen as the extended sources. They are considered as a collection of large number of point-sized sources of rays. Total variation in the amount of light entering the eye from all the individual point-sized sources will average out to zero. Thus, planets do not occur.
Fine. So if you're having your lunch break, walk quickly. Okay, please. Good. Let's do. Finish your ticket, whatever you're done, okay? You're saying this Saturday or Sunday you're having your lights?
Sunday.
There is one more test of chemistry. I think 5 tests are there in total.
So what are?
Physics,
Chemistry.
chemistry, physics, English.
2 physics, 1 chemistry, and 2 and 2 English.
Physics 1 chemistry.
now
bracket use there.
No, which this thing? Two physics is what?
What
One
two tests of
light.
Light. 2 tests of
Light only. Okay, fine.
Two tests.
Two tests.
एक test होगा.
One test for your power.
Okay, we'll do one thing. Okay, we'll do one thing. Now I'll take up a revision of your light. Okay, so that it will be easy for you to write your exam on Sunday. ठीक है? चलो. Chemistry which chapter?
First chemical.
Ayush.